Let's take a look at two more examples. Number one says 3 cards are dealt at random and without replacement from a standard deck of 52 playing cards. Without replacement means that I'm going to pick the first card and I'm going to keep it in my hand when I take the second card, and so on. So I'm doing this for 3 total cards. We want to find the probability of receiving in order a king, a queen, and a jack. So notation-wise, what I'm looking for is the first thing that I want to do is pick a king. After I pick the king, I'm then looking for the chances that I pick a queen, but since I'm not replacing, the given here is that I already have the king in my hand. I'm then going to multiply that by the probability that I get a jack, given that I have both a king and a queen in my hand. Now, notation-wise, I think this looks a little bit tricky, but it's not too bad once we get started with the actual math. So looking at a king out of 52 cards, I know that 4 of them are kings, so I have a 4 out of 52 chance there. Now I'm looking for queens. Even if I have the king in my hand, there's still 4 queens, but now I have 1 card in my hand. Remember, I have the king in my hand, so there's only 51 cards left. And this last probability, I'm looking for a jack. Again, there's 4 jacks in the deck. But now I'm assuming that I have both a king and a queen in my hand. I have 2 cards in my hand, so I have 50 cards left over. We're going to go ahead and type this into our calculator. And we get 4.83 with an E, so 10 to the negative 4th, which means I'm moving that decimal 4 spots to the left, so it becomes 0.000483. This is a very specific example. We're looking for a king, queen, and then a jack, so it's very, very rare that that would happen. Number 2 says, what is the probability of picking a king, a queen, and a jack on 3 separate draws? So this time, I'm assuming with these separate draws, what we mean is with replacement. So I'm going to pick up my king, I'm going to put it back, and then I'm going to shuffle the deck again, try to pick a queen, then try to pick a jack. So notation-wise, this time we're looking for first, the probability of a king. On the second draw, I put that king back into the deck, so now I'm just looking for the probability of a queen. And then the last one, probability of jack. So for the king, I have 4 out of 52. Since these were separate draws with replacement, I now still have 52 cards left when I go to pick the queen, so 4 out of 52, and the jack, 4 out of 52. We get 4.55 times 10 to the negative 4, so 0.000455. It's a little bit smaller here, and that's because I'm putting back that card every time, so it does impact our chances. Hopefully you notice that the big thing that's changing here is that denominator. Whenever we have those dependent events, so that's without replacement, you're holding on to the card, or you kept the gumball because you couldn't put it back into that machine, your denominator is going to decrease each time.